Hi friends, welcome back to our YouTube channel. Today we have to discuss about graph isomorphism or isomorphic graphs in discrete mathematics and graph theory course. First of all, how can you say that two graphs are said to be isomorphic graphs? Let G1 and G2 are two graphs. These two graphs are said to be isomorphic graphs if and only if it satisfies 7 conditions. First one is number of vertices. Second one is number of edges. Third one is degree sequence. Fourth one is cycle length. Fifth one is vertex preserving. Sixth one is edge preserving. Seventh one is adjacency matrix. The two graphs are satisfies these 7 conditions. We can say that G1 and G2 are said to be isomorphic graphs. Graph G1 and G2, in between them isomorphism is there. Then we can say that there is a graph isomorphism between the two graphs G1 and G2. Now we go for the example. Show that the following graphs are isomorphic or not. So this is graph G1 and this is graph G2. To prove that graph G1 and G2 are said to be isomorphic graphs, we have to consider that 7 points. First one is number of vertices in graph G1. How many number of vertices are there in graph G1? 1, 2, 3, 4, 5, 6. So there are 6 vertices are there in graph G1. Whereas in the case of graph G2, how many number of vertices are there in graph G2? A, B, C, D, E, F. That is 1, 2, 3, 4, 5, 6. So 6 vertices are there in graph G2. Next, second point, number of edges in graph G1. That means how many number of edges that are present in graph G1. So this is the first one, second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one and ninth one. So 9 edges are present in graph G1. Whereas in the case of graph G2, how many number of edges that are present? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edges are present in graph G2. Next, third point, degree sequence in graph G1 is. That means 6 vertices are there. What is the degree of each and every vertex? So vertex 1 degree is how many number of edges that are incident on vertex 1? So that is 1 to 2 is 1 edge, 1 to 4 is 1 edge, 1 to 5 is 1 edge. So 3 edges are incident on vertex 1, so that vertex 1 degree is 3. Then what is the degree of vertex 2? So 3 edges are incident on vertex 2, that is 2 to 6, 2 to 3, 2 to 1. So that degree of vertex 2 is 3. Next, what is the degree of vertex 3? 3 edges are incident on vertex 3, that is 3 to 6, 3 to 2, 3 to 4. So that degree of vertex 3 is 3. Next, what is the degree of vertex 4? So, how many number of edges incident on vertex 4? So, that is 4 to 5 is 1, 4 to 1 is 1, 4 to 3 is 1. 3 edges are incident on vertex 4. So, that degree of vertex 4 is 3. Then, what is the degree of vertex 5? How many number of edges incident on vertex 5? 5 to 1, 5 to 4, 5 to 6. 3 edges are incident on vertex 5, so that degree of vertex 5 is 3. Then, what is the degree of vertex 6? How many number of edges incident on vertex 6? 6 to 2 is one edge, 6 to 5 is another edge, 6 to 3 is another edge. 3 edges are incident on vertex 6, so that degree of vertex 6 is 3. Okay, so 6 vertices degree is 3 in graph G1. Whereas in the case of degree sequence in graph G2 is, so there are 6 vertices are there, A, B, C, D, E, F. Then we have to find out the degree of each vertex. Degree of vertex A. How many number of edges incident on vertex A? A to B is one edge, A to C is one edge, A to E is one edge. 3 edges are incident on vertex A, so that degree of vertex A is 3. Then, what is the degree of vertex B? 3 edges are incident on vertex B, that are B to F, B to C, B to A. So that degree of vertex B is 3. Then, what is the degree of vertex C? 3 edges are incident on vertex C, that is C to A, C to B, C to D. So that degree of vertex C is 3. Then, what is the degree of vertex D? So, 3 edges are incident on vertex D. One is D to C, another one is D to F, another one is D to E. So that 3 edges are incident on vertex D, so the degree of vertex D is 3. Next one, what is the degree of vertex E? So 3 edges are incident on vertex E, that is E to A, E to D, E to F. So that degree of vertex E is 3. Next one, what is the degree of vertex F? So 3 edges are incident on vertex F, that is F to B, F to D, F to E. So that degree of vertex F is 3. So all vertices have degree 3 in graph G2, whereas in the case of graph G1, all vertices have degree 3. So hence we can say that graph G1 is a regular graph, that is graph G1 is a 3 regular graph because each and every vertex has degree 3. In the same way, graph G2 is also a 3 regular graph because each and every vertex in graph G2 has degree 3. Next one, cycle length in G1 is. So here we have to consider the smallest possible cycle length in graph G1. What is the smallest possible cycle length in graph G1? So 1 to 5, 5 to 4, 4 to 1. So that is 1 to 5, 5 to 4, 4 to 1. So how many number of edges that are present in that cycle? 1 to 5 is one edge, 5 to 4 is one edge, 4 to 1 is one edge. So that is cycle length is 3. Okay, this is smallest possible cycle length. Maximum possible cycle length is, so that is 1 to 2, 2 to 6, 6 to 3, 3 to 4, 4 to 5, 5 to 1. What is the cycle length here? 1 to 2 is one edge, 2 to 6 is another edge, 6 to 3 is another edge, 3 to 4 is another edge, 4 to 5 is another edge, 5 to 1 is another edge. 1, 2, 3, 4, 5, 6. Cycle length is 3. This is the smallest possible cycle length. This is the longest possible cycle length. Whereas in the case of cycle length in G2 is, first we have to consider the smallest possible cycle length. So that is A to C, C to B, B to A. A to C, C to B, B to A. How many number of edges present here? A to C is one edge, C to B is one edge, B to A is one edge. So cycle length is 3. Longest possible cycle length here is, so that is A to B, sorry, I am taking first A to C, C to B, B to F, F to D, D to E, E to A. So first edge A to C, second edge C to B, third edge B to F, fourth edge F to D, fifth edge D to E, sixth edge E to A. So that longest possible cycle length is 6. 1, 2, 3, 4, 5, 6. Okay. Next we can go. This is the smallest possible cycle length. This is the longest possible cycle length. This is the smallest possible cycle length, and this is the longest possible cycle length. Now we can go for fifth point. Fifth point is vertex preserving. Vertex preserving means one-to-one correspondence between the vertices of graph G1 and G2. That means for every vertex in graph G1, there is a corresponding vertex in graph G2. Okay. How vertex preserving can be done between that two graphs? First, I am taking vertex 1. What are the adjacent vertices for vertex 1? One adjacent is 5, one adjacent is 4, one adjacent is 2. Okay. Next, here the one corresponding vertex I am taking as F. What are the adjacent vertices for vertex F? First one is B, second one is D, and third one is E. Okay. So by comparing these two, here one vertex degree 1 is 3 and vertex F degree is 3. Vertex 5 degree is 3, vertex 4 degree is 3, vertex 2 degree is 3, vertex 3 degree is 3, vertex D degree is 3, vertex E degree is 3. So by comparing these two, I can say that one corresponding vertex is F. Next one, I am taking 5 corresponding vertex is D. Next, 2 corresponding vertex is B. And 4 corresponding vertex is E. This may be correct or may not be correct. Okay, in the next 3 steps, we have to conclude that maybe it is correct. Okay, next I am taking this vertex 5. What are the adjacents for vertex 5? Vertex 5 adjacents are 1. Next one is 6. Next one is 4. Okay. What is the corresponding vertex for 5? That is D. Here I am taking D. What are the adjacent vertices for vertex D here? First one is C, second one is E, and third one is F. Okay. So here, what is the vertex degree of vertex 5? That is 3. Here, vertex of degree 1 is 3. Vertex of degree 6 is 3. Vertex of degree 4 is 3. Here, what is the degree of vertex D? 3. Degree of vertex C is 3. Degree of vertex E is 3. Degree of vertex F is 3. Okay. So, by combining these two diagrams, I can say that vertex 5 corresponding vertex is D. Next one is 1 corresponding vertex is F. Okay. Next one 4 corresponding vertex is E. Next 6 corresponding vertex is C. Okay. So here I have already written 4 corresponding vertex is E. 4 E. 1 corresponding vertex is F. 1 corresponding vertex is F. The remaining is 6. 6 corresponding vertex is C. Okay. Next I am taking this vertex 4. What are the adjacent vertices for vertex 4? 4 adjacents are 5, 1, 3. Next, 4 corresponding vertex here, E. I am taking E here. What are the adjacent vertices for E? One is A, another one is D, and another one is F. Okay. Here, what is the degree of vertex 4? 3. What is the degree of vertex 5? 3. What is the degree of vertex 1? 3. What is the degree of vertex 3? 3. What is the degree of vertex E? 3. What is the degree of vertex A? 3. What is the degree of vertex D? 3. What is the degree of vertex F? 3. Already we know that 4 corresponding vertex is E. Next one. 5 corresponding vertex is D. Already written here. 1 corresponding vertex is F. 1 corresponding vertex is F. What is the remaining vertex is here? 3. 3 corresponding vertex is A. 3 corresponding vertex is A. 4 corresponding E. 5 corresponding D. 1 corresponding F. 3 corresponding is A. Okay. Now how many vertices are there? 6 vertices are there. Already we are by comparing these 3 diagrams with the 3 diagrams. So I can say that 1 corresponding vertex is F, 5 corresponding vertex is D, 2 corresponding vertex is B, 4 corresponding vertex is E, 6 corresponding vertex is C, 3 corresponding vertex is A. Okay. So once we are finding out the one-to-one vertex preserving between G1 and G2, then we can go for 6th step, edge preserving, whether these one-to-one correspondence is correct or not. Okay, once the edge preserving is correct, then 5th step is also correct. Once edge preserving is not correct, then we have to correct that 5th step again. Okay, now we can go for edge preserving. The 6th step is edge preserving. That means we are taking one edge in graph G1. What is the corresponding edge in graph G2? Then it can be called as edge preserving. That can be done by using the one-to-one vertex preserving step. Okay, first I am taking 1 to 2 edge. 1 to 2 edge. That means there is an edge between 1 and 2. Okay, what is the corresponding edge here? 1 corresponding vertex is F. 2 corresponding vertex is B. So 1 to 2 edge correspondence is F to B. F to B. Okay. Next, second edge 2 to 6. 2 to 6. What is the corresponding vertex for 2? That is B. What is the corresponding vertex for 6? That is C. So 2 to 6 is an edge in G1. The corresponding edge in G2 is B to C. Okay. Next one. Next one is 6 to 3. 6 to 3. What is the corresponding edge G2? 6 corresponding vertex C. 3 corresponding vertex is A. So 6 to 3 edge corresponding is C to A. C to A. Okay. Next one is 3 to 4. 3 to 4. What is the corresponding edge in G2? The corresponding vertex is A. 4 corresponding vertex is E. So 3 to 4 edge in G. The corresponding edge in G2 is A to E. A to E. Next one is 4 to 5. 4 to 5. What is the corresponding edge in G2? 4 corresponding edge vertex is E. 5 corresponding vertex is D. So 4 to 5 edge in G1. The corresponding edge in G2 is E to D. E to D. Next one is 5 to 1. What is the corresponding edge in G2? 5 corresponding vertex is D. 1 corresponding vertex is F. So 5 to 1 edge in G1, the corresponding edge in G2 is D to F. Next one is 1 to 4. 1 to 4. The corresponding edge in G2, 1 corresponding vertex is F. 4 corresponding vertex is E. So 1 to 4 edge in G1, the corresponding edge G2 is F to E. F to E. Okay. Next one is 2 to 3. 2 to 3. What is the corresponding edge in G2? 2 corresponding vertex is B. 3 corresponding vertex is A. So 2 to 3 edge in G1, the corresponding edge in G2 is B to A. Next one is 5 to 6. 5 to 6. What is the corresponding edge in G2? 5 corresponding vertex is D. 6 corresponding vertex is C. 5 to 6 edge in G1, the corresponding edge in G2 is D to C. D to C. Okay. So all edges are completed. So this is the first one, first edge, second edge, third edge, fourth edge, fifth edge, sixth edge, seventh edge, eighth edge, ninth edge. So for 9 edges in G1, the corresponding edges in G2 is these 9. Okay, so there is no error between them, so that we can say that so 6th step is correct from the 5th step. Okay, so now we can go for adjacency matrix in 7th step. Now the 7th step is adjacency matrix of G1. Now on the x-axis and y-axis, that means on the row wise and column wise, we have to write the vertices of graph G1. So 1, 2, 3, 4, 5, 6. Row wise I am writing 1, 2, 3, 4, 5, 6. Column wise I am writing 1, 2, 3, 4, 5, 6. While writing the adjacency matrix for G2, we have to write the corresponding vertices. One corresponding vertex is F, you have to write. Two corresponding vertex is B, you have to write. Three corresponding vertex is A, here you have to write. Four corresponding vertex is E, here you have to write. Five corresponding vertex is D, here you have to write. Six corresponding vertex is C, here you have to write. Okay, 1, 2, 3, 4, 5, 6 corresponding vertices you have to write row wise and column wise. Okay. Then you can only get the adjacency matrix is correct. Okay, suppose 1, 2, 3, 4, 5, 6. Here you have to write 1, 2, 3, 4, 5, 6. Here we have to write A, B, C, D, E, F. Here you have to write A, B, C, D, E, F. Then adjacency matrix of both are incorrect. Okay, while writing adjacency matrix for graph G2, whatever the vertices that you have to write, the corresponding vertices you have to write here row wise and column wise. Okay, now how to fill that adjacency matrix? 1 to 1, there is no self loop here, so that 1 to 1 is 0. 1 to 2, 1 to 2 there is an edge between them, so that its value is 1. 1 to 3, 1 to 3 there is no edge between them, so that its value is 0. 1 to 4, there is an edge between 1 to 4, so that its value is 1. 1 to 5, 1 to 5, there is an edge between 1 to 5, so that its value is 1. 1 to 6, there is no edge between 1 to 6, so that its value is 0. Okay, now what is the values you are getting? 0, 1, 0, 1, 1, 0. Now you have to write here F to F, there is no self loop for F to F, so that its value is 0. F to B, there is an edge between F to B, so that its value is 1. F to A, there is no edge between F and A, so that its value is 0. Next, F to E, there is an edge between F to E, so that its value is 1. Next one, F to D, there is an edge between F to D, so that its value is 1. F to C, there is no edge between F and C, so that its value is 0. Comparing the first row, 0, 1, 0, 1, 1, 0, 0, 1, 0, 1, 1, 0. First row is same. Next, we can go for second row in G1. 2 to 1, there is an edge between 2 to 1, so that its value is 1. 2 to 2, there is no self loop here, so that its value is 0. 2 to 3, there is an edge between 2 and 3, so that its value is 1. 2 to 4, there is no edge between 2 and 4, so that its value is 0. 2 to 5, there is no edge between 2 and 5, so that its value is 0. 2 to 6, there is an edge between 2 to 6, that's value is 1. We are getting 1, 0, 1, 0, 0, 1. Now we have to check here. B to F, there is an edge between B to F, so that its value is 1. B to B, there is no self loop here at vertex B, so that its value is 0. B to A, there is an edge between B to A, so that its value is 1. B to E, there is no edge between B to E, so that its value is 0. B to D, there is no edge between B to D, so that its value is 0. B to C, there is an edge between B and C, so that its value is 1. Here 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 0, 1. Second row of G1 and second row of G2 is same. Now we can go for third row. 3 to 1. So 3 and 1, there is no edge between them, so that its value is 0. 3 to 2, there is an edge between 3 to 2, so that its value is 1. 3 to 3, there is no self loop here, so that its value is 0. 3 to 4, there is an edge between 3 and 4, its value is 1. 3 to 5, there is no edge between 3 and 5, so that its value is 0. 3 to 6, there is an edge between 3 and 6, its value is 1. So 0, 1, 0, 1, 0, 1 we are getting. Now we can go for this one. A to F, there is no edge between A and F, so that its value is 0. A to B, there is an edge between A and B, its value is 1. A to A, there is no self loop here at A, so that its value is 0. A to E, there is an edge between A and E, so that its value is 1. A to D, there is no edge between A and D, so that its value is 0. A to C, there is an edge between A and C, so that its value is 1. So here 0, 1, 0, 1, 0, 1, here 0, 1, 0, 1, 0, 1. So third row of G1 and G2 are same. Next go for fourth row in G1. 4 to 1, there is an edge between 4 to 1, so that its value is 1. 4 to 2, there is no edge between 4 and 2, so that its value is 0. 4 to 3, there is an edge between 4 and 3, so that its value is 1. 4 to 4, there is no self loop here, so that its value is 0. 4 to 5, there is an edge between 4 and 5, so that its value is 1. 4 to 6, there is no edge between 4 and 6, so that its value is 0. 1, 0, 1, 0, 1, 0 we are getting. Next here, E to F, there is an edge between E and F, so that 1, its value is 1. E to B, there is no edge between E and B, so that its value is 0. E to A, there is an edge between E and A, so that its value is 1. E to E, there is no self loop here at E, so that its value is 0. E to D, there is an edge between E and D, so that its value is 1. E to C, there is no edge between E and C, so that its value is 0. Comparing here 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. So fourth row in G1 is similar to fourth row in G2. Next one, fifth row in G1. 5 to 1. There is an edge between 5 and 1, so that its value is 1. 5 to 2. There is no edge between 5 and 2, so that its value is 0. 5 and 3. So there is no edge between 5 and 3, so that its value is 0. 5 and 4. There is an edge between 5 and 4, its value is 1. 5 to 5. There is no self loop here, so that its value is 0. 5 to 6. There is an edge between 5 and 6, its value is 1. So that 1, 0, 0, 1, 0, 1 we are getting. Now we can go for this one. D to F, there is an edge between D and F, so that its value is 1. D to B, there is no edge between D and B, so that its value is 0. D to A, there is no edge between D and A, so that its value is 0. Next one, D and E, there is an edge between D and E, so that its value is 1. D to D, there is no self loop here at vertex D, so that it's 0. D to C, there is an edge between D to C, so that its value is 1. So here 1, 0, 0, 1, 0, 1. Here also 1, 0, 0, 1, 0, 1 we are getting. So that fifth row in G1 is similar to fifth row in G2. Next one, sixth row in G1. 6 to 1. There is no edge between 6 and 1, so that its value is 0. 6 to 2. There is an edge between 6 and 2, so that its value is 1. 6 to 3. There is an edge between 6 and 3, so that its value is 1. 6 to 4. There is no edge between 6 and 4, so that its value is 0. 6 to 5. There is an edge between 6 and 5, so that its value is 1. 6 to 6. There is no self loop here, so that its value is 0. So 0, 1, 1, 0, 1, 0 we are getting. Now we can go for this one. C to F. There is no edge between C to F, so that its value is 0. C to B. There is an edge between C and B, so that its value is 1. C to A. There is an edge between C to A, so that its value is 1. C to E. There is no edge between C to E, so that its value is 0. C to D. There is an edge between C and D, so that its value is 1. C to C. There is no self loop at vertex C, so that it is 0. So here 0, 1, 1, 0, 1, 0. Here 0, 1, 1, 0, 1, 0. So that by comparing the adjacency matrix of G1, it is similar to adjacency matrix of G2. Okay, so 7 points of G1 is similar to 7 points in G2. Hence, we can say that graph G1 is isomorphic to graph G2. So that means there is an isomorphism between graph G1 and G2. Hence, we can say that graph G1 and graph G2 are isomorphic graphs. So, G1 and G2 are isomorphic graphs. Simply, we can say that graph isomorphism is nothing but for appearance purposes, they are appear differently, but considering the inner behavior of graph G1 and G2, both are same. Hence, we can say that graph G1 and G2 are isomorphic graphs. I hope all of you understanding this video. If you have any doubts, please put your doubts in the comment section. I will try to clarify your doubts. If you really understanding this video, please subscribe my YouTube channel, DIVVELA SRINIVASA. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. Thank you one and all for watching this video. In the comment section, I will give the entire playlist of discrete mathematics and graph theory course. Go through that link and understanding the videos and getting more marks in the external examination. Thank you one and all for watching this video.